Okay guys, today we're doing 3.8 simple trig derivatives. We're just going to be dealing with sines and cosines and a couple others. Okay, let's get this started. Okay, first thing you need to know, and I'm probably going to go forward because I'm trying to get my clicker to work here. There we go, okay. The derivative of sine is cosine, okay? The derivative of cosine is negative sine. Now, this is my old method of doing this. I don't do this anymore. I use a clock circle here. Okay, so I say in order to remember this, okay, I'm going to give you a way to memorize this. Write down sine, write down cosine. Negative sine, negative cosine. Okay, the derivative of sine is cosine. I just told you that. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. The derivative of negative cosine is sine. So we got a clock. As you take derivatives, you just go you go clockwise, and it'll tell you what the derivative is. So what's the derivative of negative cosine? Sine. Okay. And then here are four that you are just going to have to memorize. Okay. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant cotangent. You're just going to have to memorize those. I don't have a real solid method of memorizing it. I don't know if there is one. But one thing that I have had students recognize is that the derivative of ones that start with C are always C's. And the derivatives of ones that have T's or S's are always T's or S's. Yeah. Okay. Write those down. Let's get started here. Let's try it out. Okay, find the instantaneous rate of change of 5 pi over 6. Okay, remember, instantaneous rate of change is another way of saying find the derivative at 5 pi over 6. Okay, so we need to take the derivative of this. So let's do that first. The derivative of 2 is nothing. It goes away. The derivative of cosine, I'm going to draw my little thing over here, sine, cosine, negative sine, negative cosine. Derivatives go clockwise, right? Okay, the derivative of cosine is negative sine. The 3 sticks with it. So negative 3 sine of x. Now I just realized I have a t in here. Switch that to be an x. Everything else is x's everywhere. I don't know why I put a t. Okay. So there's the derivative of that. Now it says we want to find it at 5 pi over 6. So g prime of 5 pi over 6. I mean negative 3 sine of 5 pi over 6. Okay, so it's going to be negative 3 over 1. I always put them onto a fraction because this is going to turn into a fraction right now. Sine, remember if you see sine, that's square root over 2. You put down your ring finger for pi over 6. That's your reference angle, which leaves 1 sine up. And then you just need to see if it's positive or negative. So all students take calculus. We would be in the second quadrant because this is 1 less than the denominator, where signs are positive. So this is going to continue to be a positive. So just multiply this out. Negative 3 times square root of 1. Remember this, square root of 1 is just the same thing as 1. So we got negative 3 times 1. So negative 3 on top, 1 times 2, 2 on bottom. That is our slope, our instantaneous rate of change right here of that function. Let's go forward. Okay, it says find the derivative of secant and plug in this number. So find the slope at this point. So let's get our pencil here. The derivative of secant, that's one that you just got to memorize. It's going to be secant of x times tangent of x. That's the derivative. Here, I'll call it y prime. It's the derivative of secant. Now I got to plug in 4 pi over 3. So y prime of 4 pi over 3 equals secant of 4 pi over 3 times tangent of 4 pi over 3. Okay, well, we're going to do these one by one. And you know what? I will do it underneath it. So forget about that equal sign I put there. Okay, remember if you see secant, you put 2 over square root. If you see tangent, put square root over square root. We'll be dealing with the positives and negatives. All students take calculus. Okay, remember, put your reference angle down on your finger. Pi over 3 is going to be your index finger. Secant is the same thing as cosine, meaning that there is a one number up. Okay, over here for tangent, remember tangent is the same as sine over cosine. So there are 3 sines up and 1 cosine up. Okay, let's just see if these are positive or negative. Okay, that's going to put us in the third quadrant. Tangent is positive, so this stays positive. Secant is negative, because it's the same as cosine. So we're going to put a negative on it. We're just going to multiply across. Negative 2 square root of 3 over square root of 1 times square root of 1 is 1. So our answer is negative 2 square root of 3. That is the slope at that point. Okay, these are the ones where people have difficulties. Find where they have parallel tangent lines. They're bad at these. So, remember, parallel tangent lines. That means we're going to be setting the derivatives equal to each other, because this means equal slopes. Derivatives equal to each other. So our end goal here is f prime of x equals g prime of x. F prime of x. Okay, so the derivative sign is, set up your little circle, it's going to be cosine of x. Derivative cosine is negative sine of x. Okay, so now we're just going to try to figure out where these things are the same. Okay, so I mean, there's multiple ways of doing this. The way I do is I look at my hand, and I wish I could show you my hand method right now. Look through your fingers and see when sine and cosine, because remember, sine and cosine come out to be square root over 2. Both of them do, right? So which finger do you put down that makes it have the same number on the top in the top of these square roots? And that would be, if you're putting down your fingers right now, that's going to be when you get a 2 into both of these. Yeah? And that's going to be at the value, your middle finger, which is going to be at pi over 4 is where that occurs. So we know x is going to be, these things are equal at pi over 4. But here's the problem. This one is negative. If it wasn't negative, if it was positive, if we were just asking when is sine of x equal to cosine of x, you would say, oh, at pi over 4. That's where they're equal. But it's not just that easy because we have a negative here. So what we're going to do is we're going to set up a all students take calculus. And okay, right here in the first quadrant, they are not equal because this one would come out to be square root of 2 over 2, while this one would come out to be negative square root of 2 over 2. Those are not equal. So what about in this quadrant, where sine is positive, but cosine is negative? So in this quadrant, that would make this one negative, and this one would stay negative because it's just positive, but it had a negative in the front of it. So they are equal in the second quadrant, which would be at 3 pi over 4. Okay? Now let's check if there's any other points where they would be equal. Right here where tangent, so the third quadrant, where tangent is net positive, everything else is negative. Well, if everything was negative, that would make this positive, yeah? And it would make that negative, making them different values. Okay, in this last quadrant though, where cosine is positive, that would make this positive, and sine would be negative in this quadrant. So you'd have a negative times a negative, making it positive, and they'd be the same value. And that would be at 7 pi over 4. Okay, and that would be your answer. Now, what they will normally do on here is when they say like a trig function, they're going to say find where they're equal from 0 to 2 pi. And they might give you brackets or parentheses, it doesn't matter. But in this case, it did not tell me where, so there would be an infinite number of places at which they would be equal, but I only wanted to look for that unit circle one time around, which would be from 0 to 2 pi. Okay, on the test, they will tell you what domain that they want you to be looking at. That's it.